how we found antimatter just using an equation and without being totally unable of seeing it. So this universe allows us to live fully, to develop us absolutely totally without knowing the substances. An inner feeling of consciousness. We cannot define what it is, but we all know we have it. We all know we exist, we feel. All of this, we should already have a contact of an alien civilization, let's say, and we don't.
The following is a conversation with Jean-François Becquaert. He is a doctor in astrophysics at the Paris Observatory, and he was my professor of philosophy of cosmology. He is a brilliant mind who is not afraid to talk about the open problems in modern physics, and together we discussed topics like the nature of time, the hard problem of consciousness, the relationship between math, physical laws and reality, and the future of humanity. Also, he is very passionate about the relationship between art and science. This is the first episode of the Mentolo podcast. I hope you'll enjoy this conversation as much as I did. If so, please consider subscribing, sharing and supporting this project. And now, here is my conversation with Jean-François Becquaert. How would you define time?
I would not define time. We manipulate time. We have learned to model it, parameterize it, but I do not think that everyone has a glimpse of what time is. According to some theories, let's refer to relativity. In relativity, time is just behave as a dimension very similar to space, and so it's some sort of a space, but it doesn't behave as a space. And even in this theory where time is a fourth dimension, there are many philosophical issues, like speaking of the block universe, for instance, where we all are totally passive. So there are a lot of issues associated to this model. So it doesn't solve anything, and it doesn't tell us what time is. And basically, no one has an idea. And this question of time goes very far in human history. Ancient Greeks were asking, what is time? Maybe nothing, like Parmenid, maybe a flowing river, maybe, and the question goes until in Middle Ages. So it's a famous sentence from Saint Augustine: if you ask me what time is, I know it, but I can't explain it. So there is some sort of a it's a deep mystery. Time is a deep mystery, and what physics allows us to do is just modeling it, approaching its behavior, but without knowing what is its essence.
So it's like we can have models of it, or we can create mathematical objects that can be used to study it, yes, to model it, without knowing what it actually is.
Exactly.
But do you think this is true also for all the other things that we study? Like, I don't know, for if we want to model a ball which is bouncing, we do some kind of model, but in the end, do we really know what a ball is? Like, is it true only for time or for everything else that we model?
I believe it is true for everything else. Certainly time has some sort of additional mystery, I would say, because
it's very
the thing is macroscopically, when we launch a ball, I mean, a kid doesn't. It's not important for a kid to know what really a ball is. Every time he takes a ball in his hand, and us as well in our cognitive environment. The ball reacts in the same way for all our lives. So it does, of course, it doesn't at all say what is a ball, but it doesn't influence our everyday life. So but time is a more profound mystery in the sense that, of course, we don't know what it is, and we will come back on what is matter and space and so on, but time affects directly in our lives. We grow, we get old, we ultimately
we
die.
Live inside
we
time.
die because of time. We don't die because of a ball, I mean, generally speaking. But but the question is perfectly sounded. A ball is ultimately, says science, made of very small constituents, which can be even smaller, and maybe there are things even smaller, and indefinitely maybe, we don't know. Quantum mechanics says it's not indefinite, but it's just a theory. And it goes to a certain minimum scale, says a theory, but at this scale we really don't know how matter behaves. So if you think of a ball made of very small constituents, we just don't know where are these constituents. And basically, the fact that a ball is here rather than there is still a mystery. And this is very, I know it's far from everyday life experiment, but it is what science is right now. But to come back to your question, so this is matter, but space is, again, more cognitive. We don't have a sense for time in our body. Our cognition goes through space, eyes, ears, perception globally. And most of our senses are made for our survival. We know we see a mountain because this mountain may be something important to get water. And our cognition is entirely driven to survival. So first, cognition does not show us what is true. It only shows us what is important for our survival. That's the first thing to get convinced of. This being said, even with tools and so on, what we get from the real is through space, mainly. And so time is kind of a mysterious substance that is very, very mysterious. This comes back to your first question. I would say that yes, physics models things. A part of these things seems familiar due to our cognition, but if we think about it, it's not. And time is especially mysterious.
Yes. So do you think we can perceive time due to the changes in space? Because we are more used to reason by evolution, by other factions in space terms, so we can perceive time because we perceive its change. So
yes,
is it like that?
Yes, so you have two ways to approach time. Again, there is no definition of time. You have an approach of time. There are two ways. So one you mentioned is called relational approach. It says basically, imagine a universe where there is no matter, so no way to see any evolution. So a universe where there is no movement, then it would be basically impossible to do every kind of measure of time, and we basically would not know that there is time. Imagine a universe full of photons, a particle of light. This, says a theory, photons do not feel time. Their proper time, says relativity, is null, meaning a photon gets everything around instantly, every information around instantly. It's called a light curve in special relativity. So in this kind of universe, there is absolutely no way for photon to distinguish a succession of instants. So basically, there is no time. So this is a relational approach saying basically without something relative matter of a universe with some sort of complexity and entropy. Something says that there is some sort of an order, a macroscopic order in the universe. We would not be able to approach time. But there is another way which is called more absolute approach, like Newtonian approach. Saying it is a full dimension, and in a way, general relativity is kind of a mix between. General relativity says basically, in a way, Newton is somehow right. Time is a full dimension, and so it's independent of the content of the universe. Even if in a universe which is empty, no matter, nothing, time still exists because it defines the structure of the universe. It's not dependent of anything. And so the slight difference between Einstein and Newton is that Einstein says, well, it's a dimension. But this dimension is intertwined with space. They are not totally independent. It's not a cube. It's some sort of a geometrical form, all mixed up. It's some sort of a geometry of space and time, says the relativity. So in that way, time is absolutely defined. It's a dimension. It's a structure of the universe as a whole. But I think this kind of answers the question.
But so, yes, my question maybe is if it can exist independently or is forcibly attached to space. Like in general relativity, they are a single thing, time and space. But could time exist independently? Like, or maybe in new theories, is something independent time, or is still combination of multiple objects?
So, for you and globally for people interested in the philosophy of time, I suggest, and I will answer, of course, but I'd suggest the reading of two very interesting books, which are the first one is from Carlo Rovelli, and one of the contributors of quantum loop gravity. So for the people, for the auditor, quantum loop gravity is a modern theory trying to marry general relativity and quantum physics through a new approach. It's called quantum gravity. So it's a way to approach this major difficulty in modern physics. And in what is very interesting is that this new theory, quantum loop quantum gravity, has two opposite interpretations. Carlo Rovelli, in his book, the name it's the book from a couple of years ago now, says basically he interprets this theory as to say basically time is really an emerging property. It's not fundamental. What is fundamental is not even space. It's something deeper. Let's call it a mathematical object called spin network. This kind of spin network, you could imagine them as a crystal spinning and vibrating, and through this vibration, space is created. And time is not. Time is when you look at this, this bubble of space around mathematical crystals. They have quantum properties. They can be in a superposed state, and this superposition is what time comes from. Time is just an illusion coming from a complexity of model, says Carlo Rovelli. But Lee Smolin, which is the second contributor of this theory, says exact opposite. He says in his book La Renaissance du Temps, Rebirth of Time, published by Juno a couple of years ago. It's a very good book. And says basically, no, it's a misinterpretation. I'll say time is absolutely fundamental, saying that without time, in fact, a vast number of things are simply not defined in physics. Plus, we arrive in some sort of a sterile way. It's sterility of ideas. If we perceive the universe as universal, permanent, with laws pre-existing, I mean, in a Platonic universe, then we face major difficulties in theoretical physics. Because in a way, it would be very interesting, for instance, to consider that laws in physics are evolving. They are not necessarily eternal. Like, for instance, the Newtonian gravity, I mean, of course, it's an approximation, but it wasn't always there. When did it appear? Maybe its form has changed. Maybe it was some other mathematical law, and then evolving. So, universe as a whole would be something evolving. So, time is absolutely fundamental to make it evolve in globally. And maybe laws themselves are not transcendent. They are immanent and evolving. So you see, what is so interesting in philosophy of science, and I think it's a very interesting example, is that the same theory, the same physical theory, is interpreted radically different by the two main contributors of the theory. It's very interesting, and it points out more generally the question of how can we really interpret any physical theory based on this example. I mean, we can, but it's a debate of ideas, and well, these two physicians have totally opposite view on the time based on this theory.
I'd like to move to the topic of the relation between physical laws, mathematics, and reality that we discussed, and I think it's really interesting. But first, about the possibility of physical laws of not being constant and changing over time, but still they could evolve with some kind of law, like there are either two possibilities: they change randomly, or they're constant, or they evolve with a certain law. So it's a bit.
I do not know anything in which laws would evolve randomly. Of course, if laws evolve, let's assume they evolve. If they evolve, they must evolve according of the global universe inner properties. For instance, Smolin has created a model it's called it's a model of, it's some sort of Darwinian, but with black holes, saying that black holes may contain universes, I mean pockets of space-time with maybe different properties, but in this pocket of space-time there are black holes creating pockets and so on. So some sort of a tunnel of black holes of various size, properties, and what he proposed is that imagine in one of these pockets of space-time there are certain laws. Then if these laws allow for new black holes to emerge, then we might call this space-time fertile. New new space-time are created with a certain number of depths and ultimately maybe arriving to a sterile space-time in which there are no more black holes, for instance. This is just a model, but imagine the interest of that is that he proposed something which embedded black holes in one another, but there is a constraint saying that first a pocket of universe which would not be able to create a black hole, maybe it has laws and maybe it's random laws, but if a universe has some properties, it evolves creating new black holes and so on, so laws would be such that this pocket universe would be there or not. And so it's some sort of a natural selection of universes. And it put constraints. The limit of this model is that we do not see how it interacts from one backlog to another. But it's interesting in that in saying that let's imagine a pocket of universe in which there are laws, maybe other pockets around influence. So there is some sort of an environment, maybe. So that's the first thing. The second thing is to consider, for instance, the universe as something alive, some sort of a being. So evolving and modifying itself from inside. Like it's there are limits to metaphor, I'm well aware of that. But we could see that as maybe. Let's be honest. List-Moline doesn't propose a way to. He proposed a way to test if laws have evolved in history, but what would be the engine of this modification is not proposed, and of course is in a minority of physicians. The vast majority of physicians, probably 99% of cosmologists, look for transcendent laws, but it poses lots of philosophical problems. It means that laws would be prior to the universe. But why, what, and how? And but if you consider reversely laws being part of the universe and thus evolving like everything in the universe, then in a way the universe is really a whole. And the question of how could anything be exterior to the universe is not asked.
Yes.
That's the main philosophical interest.
Yes. Yes, but what's your take on that? Do you think that physical laws are something that comes before the universe, like logical ideas? The fact that 2 + 2 is equal 4 is true even if there was no universe, even if.
Yes, that's again it is a very deep question. I will provide you my personal answer. Not I can explain the auditor what is at stake here. What is at stake here is a philosophy of mathematics or philosophy of the centrality of the mathematics. The question is basically why mathematics are working so well, And it's not that they work. This is probably understandable in a cognitive way. In a cognitive way, our brain is made. So I said made for. Constructed through survival. So we have to be able to count objects around us. Of course, how many tigers are there? 1, 2, or 13? It's not the same question, right? So we are made to do arithmetics. We are made to count how many fruits we have, otherwise we would die. So basically, our brain is certainly cognitively driven by some sort of basic mathematics. But that absolutely does not explain why the universe itself, if it's not a natural being, evolving natural being like nature in a sense way, why it is designed so mathematically. Saying that, for instance, nobody really, everyone is in wonder how we found antimatter just using an equation and without being totally unable of seeing it. Predicting the existence of antimatter based on an equation without any tool in laboratory is one of these examples of amazement that one can feel for some sort of a mathematical structure in the universe. Now, seeing that, we have to be careful. It's very tempting to see the universe as a cathedral, fully mathematical. We still don't have this proof, and for instance, a lot of things are very hard to model mathematically. So what is at stake in your question is more than physical laws are mathematics prior to physical laws, and probably the answer would be yes. Now, can we affirm that mathematics are really the full foundation of the universe? It would be a hard step to make. That's the general answer. My answer is maybe a bit more. I would think that yes, there is ultimately the mathematical structure of the universe is of extreme high degree, I think. And now the question is, where would our consciousness rise from this mathematical structure? And I don't pretend to have an answer, but there must be some sort of a mechanism. Like sometimes I see you see a flower blooming, and it's the center of the flower is very geometrical, and it blooms, it grows, and finally you do not see any more mathematics, and you see a flower. And so maybe consciousness is some sort of an emerging property coming from extremely complex mathematical structures. That's a way to see it. I must also mention another possibilities, which is also very tempting. I really hesitate between the two things that I will say now. Between these emerging properties of a nearly totally mathematical universe, and the other part, and I'm very tempted by this one, which is more some sort of a dualism. You could imagine a universe deeply structurally mathematical. It would be an inert, not living universe if it's mathematical. And in this mathematical, we don't explain how or why, but there would be some sort of an essence which would be totally different from this universe. And we would call it conscience or spirit or soul or whatever, but it would be, universe would be a dualism between mathematics ultimately and this non-mathematical essence called consciousness. And so I do not have a clear answer to give you. Actually, now I kind of tend to a more dualistic way. I see consciousness as, I think, something very different from mathematics, but I perceive the universe as a highly mathematical structured object.
So, do you think that what we have been discussing is fundamentally the question whether math is invented or discovered? Like math is invented if it's just a human tool that exists in the universe, and instead is discovered is if it's instead coexistent of the universe. Is it in the end, this is the question: is math invented or discovered? Means mathematics is something that we developed to understand the world, or maybe physical laws are embedded in the universe, or they come before the universe.
So my view on this is that I think that the universe is mathematical but it's some sort of an ancient way to see the universe as something inert, something not living. And in this inert, in this non-evolving universe, imagine a cathedral, really totally geometrical and mathematical. And so we would have separated in a way, and having evolved in this mathematical universe, we probably have developed some senses. I mean, not senses in a cognitive way. Let's even have a brain. So I really think that our brain is a sixth sense. And by the way, it's one of the most mysterious things. We are. I do not think that we are essentially material. I must be frank. I don't know if you will ask me the question, but I do not think that no one can pretend that physics can explain everything. It is an approach. So if we take that, we must find some ways of thinking to try to define and approach the problem of consciousness. And it's a extremely profound problem. And that being said, to answer your question, maybe it's some sort of a loop that the universe is mathematical. We have arose from this universe, probably hearing the universe, so having the ability to kind of listen and penetrate the mathematical structures, which are totally invisible, some of us at least, not everyone. And I think everyone has the capability. That's the first thing. We human beings, we all have the same capabilities. I think some are stronger, some are bigger, some are, but basically we all have. And so I try not to go too far, but we all have these capabilities because we are human beings and we are embedded in a mathematical universe. So there is absolutely no reason for people to be totally deaf and blind to mathematics, or maybe there are social reasons or whatever reason, but it's not biological reason. So the other thing to say about that is, so in a way, everybody is capable to see or to penetrate at least a little this mathematical realm. So apparently pre-existing. You know, even if a lot of people are Platonic without saying, lots of particle physicists working in CERN or Brooklyn laboratory, they finally tend to consider elementary particles as just numbers. We don't know if particles have substances. Let's take an electron. An electron, everybody seems to know that everybody knows what it is. It's electricity going in tubes, and everybody has some sort of feeling of that. But in fact, no one knows what is an electron. We all learn we all learn when we are 12 or 13 or 14 at college that it's supposed to be a particle with this mass, a negative charge, and so on and so on. But that doesn't tell anything. It's just properties. We don't know the substance. Is it rough? Is it? It's totally non-cognitive to say a particle has just a couple of properties, and we don't know what it is. So basically, it's just numbers. And when you look into physics in general, we lose more and more in theory. We lose contact with cognitive senses, and we arrive to numbers. So it kind of gives us the impression that finally numbers are just what remains of everything.
It's in the end the question of the beginning of the ball and of time. Like if we go deep enough, we don't really can see, like we cannot really define things. We can model them. We can maybe define properties, but what they are in their essence, we cannot grasp it.
Yes, but maybe we can reassure a little bit the auditor. It's not, we human beings ask questions. That's what makes us noble. We go as deep as we can to ask the more fundamental questions. So this is very philosophical. Of course, it's not linked to everyday life. So to take an example, we all know that a cooker of pastry does absolutely incredible desserts, not knowing the chemical constitution of an alcohol of I don't know, vanilla. It doesn't. The universe allows us to do extraordinary things, art and creation and beauty. There is no equation for beauty, and so this universe allows us to live fully, to develop us absolutely, totally, without knowing the substances. So it's yes. So physics probably will never tell us what a ball is, but it's nothing compared to the smile of a kid playing with a ball.
Yes. So we can use it. It's like a gift. We can make use of the universe without understanding it, without needing to.
It's very noble, and I think we should ask fundamental questions. But we should not feel depressed if we're not capable to answer it fully. First, we have improved. For instance, now the questions we ask are a little more accurate. And second, sometimes it happens that some possible answers tend to be less and less likely. So we kind of narrow answers without being totally sure of what could come next. We have to keep our mind as open as possible. And I think quantum physics is an excellent example. We all know that at the beginning of the century, physicists tend to know that everything was known and so on and so on. And then came this theory, just the study of something called a black body with that shines at a weird way in high temperature. So very small thing.
Mm-hmm.
And then the theory was built block by block, and then what it says on the world now is totally non-cognitive and says that the world is somehow extremely fascinating, with parts communicating to other parts without the notion of distance. Time can be reversed, like future can have an effect on the present, which us living beings would not even imagine. But this is so this physics has nearly come from kind of nothing, just the emergence of the iceberg, just a couple of meters of ice above the ocean. But in fact, it had changed anything. So who now would bet that, for instance, in 1 century, a new theory will not revolutionize everything in what we perceive of the world? I think if we were wise, we would say, okay, I have seen the evolution of the physics and the images of the world that physics have given us through the ages, and it's not linear. It's not linear. It's not a constant evolution towards truth. It's not that. Physics and the philosophy of science absolutely does not say that at all. We are not converging towards the truth. Probably there is no truth, and for instance, a very intriguing and fascinating thing of quantum mechanics is maybe we participate to this truth. We are not just observers. So you see, questions are asked differently thanks to physics. So physics is helpful. Physics is helpful. Even if we won't know, we will maybe never know what is a ball, we might ask more interesting questions than before, and which changes the way we view the ball, for instance. For instance, to quote quantum mechanics, a ball is not located really somewhere. It's a bit everywhere in space-time. And this, if you think about it, of course we don't think about it regularly every day, of course, but it's somehow fascinating, because it means that the universe as a whole cannot be distinguished in objects. It's just a unity, just like a complete ocean.
Yes.
And it's really impossible to distinguish a body from another body, even a living one. And even this table is
But consciousness,
in a way, part of this unity.
Yes.
And it means that we have our cognition, our brain, has separated things, mainly for survival, and to maybe happiness also, maybe other aspects of but it's just for survival, and basically there is no fundamental difference between the universe as a whole, and it's absolutely fascinating.
Yes. We're gonna come back to this later about consciousness, because for sure. And also want to say that the idea that to think that object like flowers comes from mathematics is really interesting and fascinating. But still, math is not math by itself. It's math that has to have some object on which to operate. We could imagine some kind of mathematics that does not exist in reality, and so it's like it's math applied to some kind of objects that operate according to that math.
I think that this question is...
Or maybe matter can emerge from mathematics. Like, yes, this is a
I think when you go really, when you zoom on the universe, the higher you zoom, the more mathematics you will see. But a lot of philosophers have worked on the problem of emergence, and for instance, degrees of complexity that changes. It's very mysterious, but emergence is saying basically that the whole is superior to the sum of the parts. It's called, or we can also call it a Gestalt effect, saying that we are greater than the collection of ourselves, which is seems of course obvious, but for more simple things, it would be even true. And so someone like Arthur Koestler, for instance, has introduced a concept called holons. It's a sort of you can imagine it as some sort of a map of complexity and a realm of complexity, and there are embedded the one in the others with some sort of a frontier. And when you go off this frontier to go in another realm, embedding the first one, then you have emerging properties. It's not explained really. It's not. You don't have a way to quantify this. But what it says is that, let us imagine that really the universe is made of 0 and 1. To be just elementary information. But if you dezoom, some sort of blur is happening, and you don't see 0, 1. You see, I don't know, a cloud with grays and shapes and so on. And you dezoom and you see appearing colors may appear from this blur, for instance. And then goes the rest of properties. So it is possible emergence, just saying that there are some sort of a mapping territories. There are territories in which properties of objects crystallize, and it's not necessarily linear with scale. It's not even scale. It's more abstract than this. I've always been very I've never been really convinced in this dezoom that sometimes you see on internet coming from the smallest part of an atom and then going big and going to the first human beings and then going big to galaxies and ultimately and so on. This kind of I think linear and scaling way to approach universe, in my opinion, is very wrong. First thing that should warn us about this, I mean, it's easy to add this to explain to a kid, I know, but I think it drives us into misconceptions. What I believe is not really correct in this is that it's just the opposite of what quantum mechanics says us. Distance does not appear to be fundamental. Distance is fundamental for our cognition because we need to know that a predator is at 5 meters rather than 1 kilometer. But we think that the universe is organized like that, and maybe so quantum mechanics says it's not. Basically, we don't know what it is really, space, but it doesn't seem organized with the concept of distance. which raises a lot of questions. When we say this galaxy is very far away, a million of light years, well, in general relativity, yes. In quantum mechanics, no. I mean, we can say that really. It's not really that. And if you go back to the theory I've evocated, loop quantum gravity. In loop quantum gravity, you have this sort of crystals which are not space, which has, imagine this as some sort of abstract things in nowhereness and vibrating, and space is some sort of a fluid, of a resonance from this crystal called spin network. And what I mean by that is that in this model, for instance, there is no concept. Space is created locally, and it kind of small bubbles going or like a foam of bubbles, but there is no fundamental difference between one bubble and another in terms of distance. We cannot see difference if this bubble here is far away from the other one or not. It's very difficult. So, for instance, in this theory, it's really difficult to perceive what we consider as fundamental.
Do you want to conclude?
No, you can.
It's just a very last little question about this topic, and then we can move to something else. Do you think that physical laws are simple at their core? Like when we will have a theory of everything, it has to be something kind of simple, or maybe this is just biased because we can only find those laws that we can understand and that are simple enough, or that we arrange them in order to be simple, or maybe physical laws could be completely very complex and maybe also not understandable by us.
Yeah.
In our
yes, it's an excellent question again. So you are true. Everyone knows Newtonian gravity, and we call that the law in one on the distance to the square. And this law is extremely simple. It's just a quotient between masses and the radius its square. And so people in the 18th century and 19th century sincerely believed this was driven the whole universe. But there was a question arising, like Newton, the first, was totally aware that there was problem. It was this force working instantly. I mean, if I move the moon on an orbit, does the apple falls instantly or 1 second later? He knew that there were some problems with this the transportation, the effect on. So, but the law was extremely simple, and physics from the 20th century came with more abstract laws. For instance, Einstein equations in general relativity remain are complex. You basically need to be at third or fourth year of university to really master them. But it remains relatively compact. Let's say you have you can read them. You have a lot of stuff on YouTube, and you can really read them literally, and you have it goes on one line. Let's say to be simple. But it needs relatively abstract mathematics, not too much, but relatively. And then goes the quantum mechanics. The law are again not too complex. The formalism is not that big, but again, it's abstract because it deals with imaginary numbers, so it's far from everyday life. And then goes the modern theories, trying to marry both of the theories I just quoted, and then now the degree of complexity is much higher. It can be string theories, or it can be loop quantum gravity, and so it seems to be that the mathematics behind the physics are more and more complex. So the question is natural. Will the next theory require extremely high abstract mathematics? It's a possibility. And to give you another hint on that question is in loop quantum gravity, this series, one of the theory trying to marry the quantum world and the relativity. You have this situation where space is created, it doesn't exist, and it's discrete. It's made of little small blocks like Legos, and sometimes you have holes, it's non-space. And this some sort of a structure with holes and fulls, and so on this kind of structure, if space is it just is like cheese with holes and so on, we cannot apply nearly all of our mathematical tools. All our mathematical tools are not defined on this kind of spaces. If really space is like that, is a discrete, is a numerable gathering of small pieces of space, then things like derivatives, integrals, mostly tensors and this kind of things, it's not definite. So what is left to work on this kind of spaces is you come back to arithmetics. You cannot.
You have to simplify.
You have really finite sums instead of integrals, and every theorems or formulas to simplify, you cannot apply them. So meaning that we probably won't be able to simplify. So we probably will have maybe sheets and sheets full of doubles, triple sums on integers rather than integrals. Or another way to approach it are called cellular automats. It's some sort of a simple algorithm which fills a grid, let's consider a grid, and they fill a grid, and maybe they can approach the way that we fill grids with whites and blacks.
Like the game of life.
Yes, exactly. This sometimes when I look at the game of life of Conway, it makes me think of loop quantum gravity, you know? And how holes and in these grids are filled by some sort of an algorithm. But again, these are very deep questions, because if we find someday that there is an algorithm that has filled the grid of the universe in a way, then who has computed this algorithm is a big next question.
Yes, okay. Here there is the whole topic about simulation that we can discuss, but I will leave it maybe for later. I have just two things that came to my mind when talking about this, is that maybe in the future, only with the help of artificial intelligence, we're going to be able to develop new laws that maybe only computers can develop and understand, and we can just use them without knowing where they come from because they are developed by computers. And also that maybe just maybe a reflection that the universe must be complex enough to allow us to exist and to comprehend it. So maybe the laws at the base cannot be so simple if they must be complex enough that they allow for beings to exist inside that system to understand it. So maybe we cannot pretend the physical laws at the base of the universe to be easy to understand.
I see two ways to approach this question. The first way is to stick to some sort of dualism. If you think as there is a universe made of matters and laws and structures, and you have consciousness and so something else. And what we say basically is that in this view, there is nothing that can tell us that someday, eventually, anything material will get a conscience. Some people believe that so IA is some sort of it's just metacomputing, but it has nothing to do with our ability to see the structures of the universe. And if you look at the progresses of artificial intelligence, I see. I'm not an expert, but I see them more on a quantitative way rather than really qualitative. Meaning that I do not think that we have made for now any algorithm capable to create another algorithm. We have made algorithm. It's very impressive. I mean, you look at AlphaGo, or when you look at even more for chess, because it's much more limited. But these algorithms are learning algorithms, and they are controlled by humans. So even with face recognition used by Google and so on, it's extremely parameterized by humans. And finally, it's if the algorithm is complex enough, it is able to set its own parameters, but not all of them. So we must be very aware that artificial intelligence is some sort of big word, but behind it, intelligence is some sort of a metaphysical quest that we are extremely far to achieve, and I personally don't think we will ever achieve. I think we human beings have some sort of, let's call it a conscience in general, not us human beings alone, but we certainly have a direct way to understand and to perceive invisible structures. And we have always tried to create automats in either physical, either machines, either working to make our life more easy. And artificial intelligence is just another machine. But to answer your question, will it be able to solve for us the mysteries of the universe, like sometimes we see in science fiction movies? Personally, I'm really not convinced at all. Not at all. I don't think I'm in the majority of let's call people or philosophers. So I'd say the question is divides. It's really 50-50 in a way. For instance, someone like Roger Penrose, you will find on internet interviews in which he explains how consciousness cannot be reduced to any mathematical model, so cannot be put into algorithms. And we are really speaking of consciousness, discovering the structure of the universe.
Okay.
I cannot see, if you imagine how kind of intelligent it requires to develop an equation explaining how a quasar works, and then launch observation and correcting your equation or refuting your equation, discussing with other people, melting ideas, coming back or improving, all this kind of high-level structuration, let's call it meta-structuration in physics, is what is the main engine of physics. And this is not one human being. Yes. It's very easy to say Einstein has created relativity. Factually, he has published an article, but he is in a mood of ideas. If Einstein was born in the 14th century, of course he would have not made relativity. It's obvious to everyone. So it's all humanity who makes this kind of thing, and it's not one spirit, and plus so that's one. I'm not only giving you my personal answer, my skepticism about artificial intelligence being able to really find by itself the structure of the universe. That's the first thing, and I would add to it finally that, in a way, if quantum mechanics is asserted in the years to come, or slightly corrected, but if the main foundations remain, and if we prove that the universe is not really totally external to us, in a way that we kind of contribute, we are not simply observers, but we are part of building a universe which time by time does not really exist. The universe, consider it as a box with the dead cat. But on the universal part, the universe is, we don't know if there are really stars and galaxies and so on. It's just in a superposed way, and we look at them, and it's just like the cat being dead or alive. We are being observers. We contribute to the universe. That's basically what it says. So, and that it goes back to this evolving laws. If objects are behaving maybe differently according to their being put into existence due to observers, whatever they are. So maybe laws are evolving partly because of that. And so if laws are evolving, how can we even think of artificial intelligence discovering this sort of a second level laws? Right now, there is nothing in artificial intelligence saying that it is more than a couple of algorithms, well set and well parameterized.
But so do you think that consciousness is needed for intelligence? That there cannot be real intelligence without consciousness?
No, I would not say that, because I really don't know that. But I think consciousness is necessary to view in some way, or to penetrate the invisible structures of the universe. Maybe more than intelligence, because intelligence it's a word. It's difficult to define this word, but I see it as a way to organize things at best around us, and to provide links and possible explanation, let's say that intelligence is the capability to modelize at best what we know around at a given time. But that doesn't say that we really feel what it is, why it is important. Because ultimately, what makes us ask the fundamental question is not intelligence, it's conscience. Intelligence is a way to modelize is a way to answer. But for instance, it's not the only one. Some people are working on intuition, are making experimental protocols on intuition. For instance, Ion Institute in California. Some people kind of feel what is going to happen, or what is an object, and what is really inside something, and it's intuition or some other things, but it's not intelligence. A lot of these people have not made any studies, but they are aware. They know how to penetrate some structures of the universe. So I would say conscience is more fundamental, much more fundamental than intelligence. Intelligence is just a capacity to organize, to optimize the organization of things around us. But it's not more than that. So maybe in that way, artificial intelligence would be very helpful. It would be a helpful tool for us to maybe help us modelize, but not to ask the right questions, and not to, for instance, giving up a model for make tabula rasa and decide that we'll go in another direction.
But
and
yes.
human beings are capable of that. Yes. Sometimes we look at, we are in a tunnel and we say, okay, we've passed too much time that tunnel. We go back and we try another thing. And I don't see an artificial intelligence having this kind of libre arbitre.
Yes. I think that we kind of associate consciousness with intelligence in some way, because really we as humans at least cannot do intelligent thinking without really being present, like being conscious. Like for us, it's really the moment we are conscious is when we are really thinking about the problem. But if you believe in evolution and that we derive from planktons or some sort of basic self-replicating cellule that then evolved into DNA and all the rest. There was no consciousness at some point, and there is now. So in some of this chain, consciousness must be created or emerge. But so why couldn't we build some sort of system to replicate this evolutionary mechanism and create an artificial intelligence which may or may not have consciousness? Because in the end, can we really prove that something has a consciousness? But that then has the same capability that we have, and maybe more, so to create in an evolutionary way, so in a sort of evolutionary algorithm, but more powerful, because really working maybe on a biological level, and then obtain an artificial intelligence that is capable of doing this, which is human and maybe more than human thinking.
I see your point. The question of the arising of conscience is, of course, debated. Of course, no one knows. There are several possibilities which are discussed. First one is probably, in a way, the most promising, is saying that conscience does not arise; it's just everywhere. Mm-hmm. Let's call it Panpsychism. There is conscience in inert objects, and there is, of course, everybody knows intuitively that there is some sort of conscience in the vegetal. You just have to put your hand on the tree to know that it's not an object, it's not an inert object, and it has something which is very different from a mineral, for instance, and probably so there is this first possible answer. So in fact, but we would not know why we would be maybe more conscious than other things, and if we are, and so that might goes with what you say, that can we make conscience appear, or in fact, can we focus conscience which is a bit everywhere?
Yes.
Can we focus it more? Can we concentrate it in new kind of bodies, maybe artificial or not? This is nobody knows. The other thing would be no answer. For instance, like in a dualistic view of the world, then you have a sort of a superposition between an inert world made of minerals, atoms, matter, and conscience, but not inside. They would be communicating constantly, but they would not be part of the same realm. And so what you would ask is, say, okay, I take matter, and matter would be able to go outside its realm and into the realm of conscience. And so the question would be, no, it's not logical, and there is no way that we know to go from one to another. So it really, it's not impossible at all. I myself said that I see limits in artificial intelligence. I think if we want to be more efficient in the future, like if we think that, for instance, mathematical laws will be more complex and more difficult to apprehend for us human beings, rather than trying to create super automats, maybe we could enhance ourselves.
Yes.
So enhancing ourselves is not necessarily a genetical modification. It's a possibility, but we open a Pandora's box, and it's in history, it's not necessarily a good thing. History has taught us that, but it could also be through other approaches. Like I don't know if someone has ever tried to melt meditation and physical thinking, for instance. In general, human activities are very separate nowadays, and I think it's not the best way, the best possible approach. I think maybe new physics in the 22nd century would be a much more interdisciplinary way to approach physics. Not only learning how to model, how to compute, how to put equations, but also to try to develop things like intuitions, things like meditation, things like interdisciplinary approach, like using arts, for instance, and creativity, and melting, having feeling textures, and I think it's a pity when you have young kids good at math and good at physics, and society may rapidly they only do math and physics, and in fact I wonder if it's the right way to approach this. Maybe for kids who are in advance on this subject, maybe on the contrary, not on the contrary, but we should give them a pencil and the colors, and they do paintings and sculptures, and they touch things, and the specialization is probably not the right way to approach this. So enhancing us is also following what quantum mechanics says. We must be more global. We must take time to have a high-level view, let's call it a seagull view, rather than a frog view. Specialists of frog view. They are extremely performant in the little lake. But I think what we need as human beings is to be more global and to be able to work more efficiently all together. What is the best? What is the revolution in computers in the recently? It's not computers. I mean, as a unity, but we make network of computers. When I was a kid, network of computers did not really exist as a concept. We all had computers, and we try to enhance computers. But what about networks of human beings? If we find a way to enhance communication, to
do you think
and to make us let us make more and more think tanks on big questions, on fundamental questions, and even on theoretical physics. Now I see that in some theoretical physics laboratories, they try to open their mind and enrich the way they can, the view with fields that are kind of far away from physics. So this is a way to as I see it, more interesting that because artificial intelligence solving all our problems is clearly a fuite en avant. Fuite en avant meaning we try to escape the problem. We give somebody something else the responsibility of us and to ask good questions. It's not the good way.
We could use it to enhance ourselves, as you suggest.
I think they could be performant for help us modeling, but not to ask the right question.
Okay. I like the idea of connecting like a network of human minds, and do you think it will be possible to join consciousnesses, like not only like having a connection which is just telepathy and understanding each other, but really having a single consciousness? Because if you, I don't know if you know of this experiment in which some patient had some mental problems and they had the central part of their brain removed, which is like the section which connects the left and the right side. I don't know the name in English. But and after this, it was like the two brains were behaving as different entities, like and they were like two individuals in the same brain, because one was the left brain and one was the right brain. So maybe it could be possible to do the opposite and merge brains and create a single consciousness of one, of two, or multiple people.
I would be more pleased if we would find a less biological way to proceed, but I don't have a clear answer on that.
Yes, it's just speculation.
It would be. I think even if you put in one room people who are open-minded, positive, and who sincerely want to enhance, just that, I think you lower communication problems and you lower egos and you lower all this. So that's the first thing. I know it's probably not what you want to hear, but it's a first approach. Then we don't know in the future what technology or quantum technology could bring us in terms of interfacing, in terms of instant communication of a large amount of data. So we should remain very open to this kind of things that could do us a lot of good if we, of course, manage to find very, very urgent answers to our environment.
And yes, you cited Panpsychism,
yes,
which is this idea that consciousness is a fundamental property of the reality, and I think it's a really interesting one, because from one point of view, it's look like bypassing the problem, like saying we don't have to explain consciousness because it just exists, and it's maybe you model the interaction of it. Maybe it's composed of quantum particles, and we are just like more and more conscious beings have more complex interaction between these particles. But at the same time, it's actually a simple explanation. So from a scientific point of view, it's like the better one, because it doesn't assume, like it's trying to be as simple as possible, and in this way is kind of a good scientific theory.
It also answers the problems of when the conscience has
yes, it also is there, but
if it's a basic constituent of either in the universe or external to the universe, it's absolutely fundamental. And lots of people have said it. Schrödinger, for instance, said that whatever physics says on the constituents of the universe, consciousness remains one of the fundamental constituents and out of physics. Some physicists and have came to the same idea that consciousness was out of the physical realm. It's a well, of course you have the open debate. You have physicists which are called totally materialistic, and who consider that proven otherwise, consciousness is an emerging property from the brain, which is totally matter-based. And a lot of brain specialists, in majority, still think that. So, but you have more and more experiments, more and more philosophers also as well, like Chalmers, for instance, who say no. You brain physicists are you have your view is imprisoned in some sort of model, but if you take a larger perspective, you should see that it cannot be this way. It cannot be this way, because if you think that really the brain is some sort of a computer. And that the computer creates images and sound, and we call it conscience. If really it is that, how that the computer knows itself that it exists? And this is one of the most deeper and inner feeling of consciousness. We cannot define what it is, but we all know we have it. We all know we exist. We feel. Color, space, time, our lives, our pain, our happiness, we feel it. We know that other human beings feel as us, and for us it defines human beings around us. But fundamentally, it's something totally of the inner self, and that hardly can be explained in if you think the brain as a supercomputer. Even the brain cannot know itself that it exists. That's basically the main question. It's called the hard problem of consciousness. If you put it in one question, it would be this one. Every computer has this software, this kind of stuff, but the question, what is the software and who did the software, is not answered. You need a creator of any software. And so if the brain is materialistic, it needs to be computed or driven or initialized, and if metaphorically, if you think about it, the materialistic view is a bit absurd. Even it really would be saying that the computer has programmed itself and has launched itself and has plugged into electricity itself. Basically, it's that materialist says. So if you really think about it, it's really absurd. So you need something else, and nobody knows exactly, but if you think of the brain less as a computer but more to a radio receiving a broadcast, and broadcast is thought. And you, Tommaso, you have a radio on 83.4 megahertz. You have your spirit, you receive this field, and I receive another field, and so on and so on.
Yes, it's like...
So the interesting thing about it is that it kind of redefines what death is. If the radio is broken, the broadcast still exists somewhere.
Yes, that is interesting. But it's interesting, the idea that brain does not create consciousness, but it uses some part of reality to assemble consciousness with what is outside of it, and so brain define identity but not consciousness. Like there is not a consciousness outside that then is that emerged from my brain, but it's my brain and the way it is wired that uses quantum of consciousness, quanta, or something else, and build a consciousness. Maybe it's something like that. But also, I think it's interesting that there is a concept of identity, like I feel like a single thing. My consciousness is a single entity, while and there exist multiple of them. Your consciousness is different, and apparently cannot communicate on the consciousness level. They cannot only pass through the materials world and then communicate to that. But so if Panpsychism is right, in some way it can create a single thing with a sense of unity, which is my consciousness, out of something that is not singular, because if my consciousness as it is does not exist somewhere in the world, and it's then put into me. I don't know if it's clear.
Yeah, I think I follow you. Let's. The question of the plurality is very troubling and very, very interesting, because and for instance, to give you some answers of philosophers, you have people like Schrödinger have finally believed that ego was really absurd, and we were a multiplicity. So it's in a way you could say with image of broadcast and radio, is that there is infinite broadcast and radio some shifted, so we do not see exactly and so it explains why we don't have the same the same soul, let's say, but basically it's basically the universe is a unity. And ultimately, it's like, or you can use another image, and this image is called from it's a very beautiful image from Henry James, and it says we think each of us as trees separated from each other, but all our roots are all together, crossing from island to island in beneath the ground. So it's all our education tend to comfort us to see ourselves as clearly separated individuals and trying through competition, through a lot of these things to separate at maximum. But I wonder if it's really the right way to proceed first, and I wonder if I think it's a dead end finally. One of the best way to explain what we see is to consider a very strong unity of universe as a whole, and probably to conscience as a whole. And if you see all little things, like even with little radios, it's you see things very differently, because even an insect is plugged and listen to this radio and is full of a little something, couple of notes, and that's his conscience. And so Panpsychism is in a way illustrated. Even atoms have a little radios and are plugged to this universal radio program. And so that's very dualistic. And when I'm saying, I'm basically saying that you have a material world and you have a ethereal world. But well, like you, if I was born in 5th century, maybe I would have a different view. But right now, I think it really holds. I think it really holds it, and it's much more better than that materialism, which is a complete dead end, in my opinion.
Maybe one last question about consciousness. Do you think that free will requires consciousness? That we must be conscious to be free, or maybe even conscious being are not free, and we have just an illusion of being free?
I am very extreme on this question. I believe that it's so. Let's be logical with all what we said. If everything is somehow conscious, then every single particle even has free will. We can be as extreme as that. And to support us, we have the free will theorem of Cauchy-Specker. It's a theorem from quantum physics, saying basically that if quantum physics is right, and if we have free will as an observer, as a human being making an experiment in a laboratory, then it must apply that electrons have free will. This is called the Cauchy-Specker theorem, and it's not as known as it should be, but it's very interesting. Let us think about electrons having free wills. It means that matter in general, if you consider matter as made of very small constituents, whatever they are, electrons or neutrons or whatever, it means that if very small constituents making as a whole have a reaction capacity, they are not. In fact, they are not totally inertial.
Mm.
They are not. They are not.
Deterministic. It's not totally deterministic.
So not only deterministic, but say that imagine. So it gives another image of the universe. It's more like if the universe was some sort of an interface. Imagine a screen, and you touch a screen, and the screen moves and changes, and does a picture, and does a sound, and whatever. The more we think about it, the more the universe would somehow look like something like that. Some sort of a tactile screen. Cauchy-Specker theorem, saying that if even little part of the matter, particles, have free will, if we have one, which probably everyone, not everyone. I have had some philosophical devoir from other. Some students tend to think that free will is far from obvious, and then we don't have free will. I've had some dissertation about that, but I personally, I'm convinced that we have a free will, and I just cannot imagine how we can live without thinking that. But if we have a free will, and this very interesting theorem from the 90s says that basically matter itself has a free will. It's very, very interesting to think about that in a way that it gives us the image of a very reactive. It's a universe. Universe is again not something inert. It's something moving, reacting to the lives inside of it. And it's a very, very interesting way. It makes the universe lively and living. And we are participating to something that we interact with and modifying it even slightly.
I think, by the way, that everybody lives as if they had free will, because you cannot live like not believing that you have free will. I think
some do. Huh?
Yes, yes. I think that.
But I do not understand either, but some do.
Yes, like even if you don't believe in free will, you act.
Yes.
And you do your everyday life as if.
That's the main argument of people, for instance, interviewers of brain specialists who are materialistic and who try to convince, mostly themselves, that a brain is just a supercomputer, and so we are no more than machines. Finally, we are programmed, we are determined by our environment, and we are totally robotic finally, but just responding to this question almost answers in an opposite way. So yes.
Let's talk about aliens. I think you're familiar with the idea of Fermi's paradox.
Yes.
Would you just say your take on that? What is it, and what's a possible explanation of Fermi's paradox?
So for the auditor, so Fermi's paradox is saying basically that we should already have aliens in our gardens or communicating with us, or considering the number of potentially habitable planets, some galaxies and systems and so on. But of course, it's a very simple way to address this question, and meaning that first we don't really know what life is. And I could, for people interested in that question, I think I could refer to an interview of Lex Friedman on that you can find probably on YouTube on two exobiologists trying to put some perspective on the question of what is life, basically. Because probably every one of us is driven by science fiction movies, and probably of course we have evolved from purely humanoid things, but even recently, we think about living oceans, like in Solaris, for instance. But we can even see much more intriguing or imaginative way to answer the question. So the Fermi paradox is basically considering a certain number of parameters. If you multiply all of this, we should already have a contact of an alien civilization, let's say, and we don't. There is nothing clear. The SETI is now working for something like 30 years around. So SETI, Search for Extraterrestrial Intelligence, is based on radio telescope, looking through 21 centimeter wavelengths. It's hydrogen wavelengths, which is a major visible constituent of the universe. And the idea is that if aliens want to communicate, they use what is the most frequent element. It sounds reasonable. And then recently, they looked at different wavelengths, but there is nothing really clear, no pattern, nothing like that. So it seems to show that maybe. In a restricted view of aliens as some sort of bipeds or things interested in communication, having reached a technological level, all these questions are very open because it's not that obvious. We have stayed millennium without real technology as we talk about it. Is technology an accident? It's another question. So maybe there are lives and maybe they're not communicating. That's another problem. I think now it's really to answer the question: are there aliens? Whatever their shape is, maybe clouds, maybe interstellar clouds, maybe things, is really a matter of faith, not a matter of science. In our nowadays state of what we know, it's hard to be. The only thing we can say is that no one close to our solar system, in our part of the galaxy, which is nearly on the middle of the disk, apparently has communicated with us in a matter of centuries, times. So the wavelengths around, and a specific wavelength. So it doesn't say much.
Yes.
To really answer the question of how much life there is in the universe, we should be able to understand how life has came on Earth. That would be an interesting input to answer this question. And very interestingly, no one really knows. We learn like it's as if in the media, like when we are kids, we have our parents give us books that life has come in the primitive oceans in the form of very simple prokaryote or eukaryote cellula. Then it gathered all together and it created the first non-vertebrates and so on and so on. And we all think that it's all clear, it's all set up, but not at all. In every gap of the process, we have gigantic mountains, meaning nobody knows how to come from a simple molecule into an ARN. So the messenger of the ADN. From ARN to ADN, nobody knows, and nobody knows from the ADN how to go to a cell, because it's like, okay, ADN is the map, and cell is the territory, and a cell is much more complex. That ADN is just let's put it this way: a coding sequence. How to build this table is not the table. And finally, we don't know who built the table. We have the plan of the table. Plan is ADN. But we don't know what is the table and who made it and how it's made, and what is that really is constitution. So, and then goes from the cell. And so from the cell to the first invertebrate, there is a step of complexity which we don't know. So let's go back to the conclusion, because I think everybody knows the point. There is a sentence from Fred Hoyle, which is very well known, saying basically, life is as if a tornado would have crossed some sort of a land full of garbage and pieces of iron and here something, and at the end, after the tornado, there is a full working Boeing 747. So this is our understanding of what is life now on Earth, even the smallest part, from the virus to the biggest part. So life and how it emerged, even on Earth, is a total mystery. We just have some little bricks, little glimpse, but we don't have the full story. And every step of the story is a total mystery. Nobody has even succeeded in creating an artificial ARN coming from nothing, coming from carbon, oxygen. So first thing is, we don't know how even it arrived on us. So it's super hard to even estimate how it could arise in other planets. There are, let's say, there is potential, because we know that there are a lot of planets having oceans. We know that. Maybe something like at least 10 or 20% of rock planets have oceans. So there are probably conditions, if it's repetitive and if the pattern is necessitate an aquatic element and so on. But does it imply that life is... would we have developed tools and technology ultimately if, for instance, life was super easy? Maybe not. So we would be a life form, but not interesting in communicating, maybe. So that's another view of it. Maybe there is life, maybe there is a great deal of life in the universe, but not necessarily interested in communicating and creating tools. I haven't answered your question directly. I've just tried to put a landscape around it. I think, personally speaking, I would not be surprised if life was very rare. And also, this question is very related to an image of the universe. Let's say a universe seen as a home, as a house, meaning that there are rooms and you can have space to develop and so on and so on. But so this is, let's call it a Newtonian or general relativity view of the universe. But if you think of the universe through a quantum filter, then if universe is a unity in which space is just a way to organize things, but it's not fundamental, we might even be totally alone, because space is a creation. We co-create space. Maybe space is just made for us only. It's possibilities that we are totally alone, and we are looking for... Why are we looking for aliens? We are looking for aliens not to feel alone, and to maybe save us. Lots of people look for aliens so that they save us from our self-destruction, which is almost programmed. But maybe it's not the case. Maybe it's not the case. If universe is what I want to say is maybe universe is very different from what we think it is. And in that view, looking for aliens it just is looking for ghosts.
Okay, yes, we have an assumed idea of the universe, but in reality,
yeah. So I think we are looking for something that won't necessarily save us. We have everything in us to be able to save us, our consciousness, our intelligence, and in a way, it's also very close to. I put a parallel with the question of multiverse. Multiverse is to me some sort of a fuite en avant again. It's we don't know at all what the universe is. There is really no point in looking for an infinity of other universe. And to me, the problem of multiverse is biased by a tendency that we have to take something and imagine its duplicates, and it's purely a way we have to again organize and trying to foresee and trying to get to try to see all possibilities. Let's put it like that. Our brain is made for our survival to imagine all possibilities to everything, and but it's not necessarily how the world works really. It's how we work for our survival on planet Earth, but it's not necessarily how the universe is based off. And if the universe is a fundamental unity, think of energy fields. Quantum field theory says everything is energy fields, and think of the universe as something, a sphere full of energy fields, all melt all together, and maybe it's maybe the universe we think as big is not. Maybe it's pure illusion. It's a perspective. It's as if we were in a mirror gallery. It's really possible that the universe it's much more smaller than we think, and then we will not be looking for ourselves. I know it's an extreme answer, and probably there is not much people thinking that, but I think it's interesting in the way that we look for things that we already have, and
yes,
and someone a native from Amazon is in a way so different culturally that we don't need to look for diversity that we already have. There are tens of millions of species on Earth, and we don't even know all of them. So yeah.
Yes, but in a way, I think it's just interesting to think about why we don't see aliens, because there are so many possibilities, even if most of them are like metaphysics, because we don't really know, like if it's just an illusion and stuff. But it's interesting also to think about our place in the universe. Like if really we are alone, maybe we have to be more careful about ourselves, our life, and maybe we have to give us a little bit more importance on our role in the universe if we are so special. Also,
yes.
if maybe it means that advanced civilizations are bound to go extinct, and so they will never communicate, and so we have to be careful about that. So it's more of a questions that can help us think maybe in a different perspective rather than giving us an actual answer of this question. So.
I've read some answers evocating the possibility that also civilization have either perished due to technological teenage, like we are threatened to, and the one who have succeeded and evolved maybe are on another planes of perception, let's say, and it would be as if who amongst us tries to communicate with a beehive? We observe it and we take the honey, but no one tries to communicate. And maybe a civilization far, far away sees us as a beehive and goes through, or maybe there are no more matter-based, but only light-based, or having maybe there are lots of possibilities. Thing is, if we sum up, I think my vision of it is that people who think about it should be aware that the question is really related to the paradigm of the world. If the world is so different that we tend to see it now, maybe in fact it has something to do with the problem. But of course, I mean, I must say that this is just an opinion, saying that I would be the first pleased to meet strange things evolving in whatever system, because if we communicate efficiently with them, we double instantly all our art galleries and our way to share, and just a way to observe and to address the universe. What kind of mathematics have they developed? What is the relation with between art and their society? I mean, there are so many fascinating questions. So I certainly would be pleased, and probably I love to see the Star Trek series, even with all trying to imagine all kind of possibilities, and of course this is fascinating. I'm just saying that it's a real possibility now, due to quantum mechanics, that the world is extremely different of what we perceive of it, and maybe the question of are there other lives is related to this question.
Like, where do you see humanity in the future, like 500 years? Where could we be? And do you think that we shall try to colonize the solar system? We shall try to go out there, or is it something is important on a human civilization level to be interstellar and interplanetary?
I've been very influenced by Arthur Koestler's book called Janus. It's basically, he says in Janus, and I think there is something true about it, that we have evolved just much too fast, considering our cognitive capabilities. Our cognitive capabilities are including our communication, our brain, our way to work, and our, for instance, capability to master our emotions, our anger, our sometimes need to destroy, and our sometimes need to the empathy. All these things should have evolved, but we have evolved in a matter of centuries, millennium, let's say, maximum. And maybe the cortex should have needed much more time. And when Koestler wrote his book, it was in the Cold War, at the end of the Cold War. Basically, it was fearing that at any time there would be a global nuclear war, like extension of humanity, mostly, probably. And so he was saying, okay, now here is a fact. Nobody has mastered his emotions. And for instance, everybody follows some Gregorian behavior. Like if somebody says, I'm your leader, and take Hitler in mind, I'm your leader, and you see all crowds following like one body, this is absolutely dramatic, for instance. And so Koestler was saying, okay, how can we correct, like something of a fast enhancement, so that our capacity to communicate, to have empathy towards each other without destroying either the environment or ourselves, could be achieved to fill the gap between technology which allows global destruction in 1 minute, and this cortex that haven't been able time enough to evolve. And he was a bit
pessimistic.
He was a bit pessimistic, but he proposed solutions such as some sort of it was not really realistic, but trying to work on chemistry, where like everyone would take pills to, and so not pills to make us zombies, not at all. His idea was if by chemistry we would be able to, I know it's unrealistic, probably obsolete, but his idea is to find a way, let's say, to enhance creativity and to enhance control of our emotions. To have, not to make us passive sheeps, not at all, but to be able to have not to act instantly, and to have some sort of a reserve perspective, and to master a little bit more how we behave and how we, and in a general view, and to be able to also to develop more empathy to every kind of beings. It's of course it's tragic that even in the 21st century we kill dolphins. I mean, how tragic it is. We have put people on the moon and we still kill dolphins. It's just so incredible. But we are like this. We are an extremely aggressive species. We have probably managed to survive without this, without muscles, and we are without even fur. And so we need to find a way, either. So what I'm giving, it's the answers I'm providing are a bit obsolete and a bit, but also there are other ways, probably, and but it would be very interesting if think tanks of biologists, chemists, anthropologists, or multidisciplinary would think on what can we do really? Can medicine help us? Can plants maybe help us? Can maybe an intervention so we need to find a way to make us more close to all of us, and close to the nature. We have a very strong capability to empathy, but we have also very strong capability to self-destruction. And that's I mean, we won't solve it in 1 year, 2 years, and we make more and more sophisticated weapons. And at some point, Arthur Koestler said, okay, it's like you put teenagers and you give them matches and you put them in a reserve full of oil, and you hope that nobody will even scratch a light. So the situation is complex, and we need to find ways to For instance, it's what happens in Ukraine now is obsolete and anachronic. And for instance, theoretically it should not happen, and it's because people are disconnected with some with probably one another, and they don't feel empathy anymore, and they plan according to historical things which are totally abstract. You have in front of you mothers and kids, but you are sure to be in your right, and you follow abstract plans based on historical views of empires and kind of stuff, and this is absolutely ridiculous. If we were, let's say, much more empathic, mastering ourselves much more. So this should be the way. Now, how to achieve this is an open question. And I don't see any other possibilities, to be quite honest. We are kind of helped by technology in various ways. For instance, we are really very close to have an infinite and clean energy with this fusion. This is the best news of the beginning of the 21st century for humanity. The prototype we make in Cadarache is the best news for humanity, hopefully. A clean, infinite source of energy, but it doesn't solve anything. For instance, we need empathy to be able to control our demography. For instance, we need. And at some point, I think we won't be able to really evolve without having a really unified government. I mean, a strong terrestrial government. At some point, it is utopic.
Yes.
But how can we really evolve without it as a community?
Yes.
It's really will someone somewhere have the courage to launch the idea really. Maybe it can cross the nations, it's a possibility, but right now the concept of nations is historically just things between two rivers or two coasts, and it's totally contingent.
Okay, yes.
And when you think about it, but we need to unify more and more and more. The tendency would be to make something more unified as possible.
Yes.
To share resources and to be able. And then to answer your question, yes, of course, it's interesting to build cities on Mars. Yes, it is. And besides, we are made to explore by thought, through science, and physically, probably we will have surprises. So yes, it is fascinating. Yes, we should do that, but now it's complicated to explain people that we should spend billions rather than saving species, for instance. It's a complex choice.
I really like the idea of this discrepancy between our evolution and the evolution of technology.
Yes.
Maybe it could be also, yes, this thing that we said before, that technology is so powerful that can destroy us, destroy the planet, and could be a solution of the Fermi paradox, like a great filter of advanced technology civilization is that they destroy themselves. And also, yeah, the fact that we have basically the same as some thousands of years ago when we were just hunter-gatherers, and we have the same minds, but in a completely different environment for which we are not evolved. And this discrepancy, as you said, can cause bad things, can cause harm, can cause can make us behave like animals in a modern society. But at the same time, it could be also the good part of humanity, like it's the driving force. For example, going to the moon as results of competition, exploring as a result of evolutionary drives of conquering and having more, and so it's bizarre because it's our animal nature, let's say, is both the origin of our bad and good sides, and so if we want to control it and maybe remove it, maybe it means in some way the end of humanity as we know it, and maybe going back to the Fermi's paradox is what advanced civilization that survived do. They change themselves in order to not be animal, let's say, and just live by themselves, not communicating with others, maybe building extreme technology to be happy and extremely advanced technology to live a happy and fulfilling life, and that's it. Like,
Yeah.
Maybe it's something like that. It's really interesting to see that different evolution speeds of us and our environment.
But we must not forget that ultimately in the general relativity view of the universe, the quantum is much more open to the question. But let's take the general relativity view of the universe. The universe is destined to death, to thermal death, and so okay, it's a billion of years. But so is planet Earth, so is Mars, so every star, so everything. So if we really look long term, we are here for a couple of minutes, and maybe what we could do at best with our lives is to bring as much beauty as we can, or trying to reach some other much deeper experience, and it changes perspective, meaning that we have problems now, so we have urgencies, that's for sure, but we need to keep in mind that there are even bigger aspects, and that it's possible that we could maybe meditate more and try to find other solutions, and besides looking for an urgent solution. If we don't survive, our question is very, very different, and we will not be able to explore matter anymore. That's the main thing. And you raised the right question, saying that without the proof of the contrary, we are one of the most interesting things that the universe has done, has produced for now. So it would be probably a shame that we extinguish ourselves without being sure that anything will come after us. We are the result of millions of years of evolution, and we destroy ourselves in a matter of centuries. It's probably a shame, yes. So yeah, I think we need to enhance ourselves in whatever possibility. Maybe why not genetically, if we find a way to develop more empathy and control more our most deepest dark parts, let's say, and
yes,
and as Kessler put it very rightly in the book, it won't make us sheeps. It's just mastering our dark parts. Will not make us robots or automats at all.
It's to gain some freedom on ourselves.
We will, of course, there will be less tension, but for instance, I think it's very reduced to see art as a tension between, let's say, evil and angels. Of course, lots of artists cultivate this thing of drinking, having drugs, and destroying the body, and so on and so on. But it's not all art. It's just a part of it, and it's absolutely not proven that you're better at it because you exacerbate the dark part of not at all. Absolutely not.
Mm-hmm.
It's fascinating, but it doesn't make better art. So people should not be that afraid of trying to. I mean, if there was some sort of a miracle pill that makes me closer to every human being and made more control of my deepest sensations, that I think I would take it.
What is for you the meaning of life? In very short answer that you apply like on everyday life, whether conscious or not. What in 2 lines?
Learning at maximum, discovering at maximum, trying to bring as much beauty as I can by writing, by doing art, and trying to bring as much light as I can to me and the others.
This was my conversation with Jean-François Becquaert. Now let me conclude it with some words of wisdom by Carl Sagan. If we crave some cosmic purpose, then let us find ourselves a worthy goal. Thanks for listening. This was the Mentolo podcast, and I hope to see you next time.